Hi students, Miss Nieves. I hope you all had a lovely weekend. I did have a pretty good weekend and I'm really excited for the weather changing. The weather is getting a little warmer and it's so nice out. I hope you're having a little bit of a chance to hear the birds sing outside and enjoy the sunshine on your skin. Okay, so for today's read aloud, we're going to continue where we left off last week. We were talking about the planets, and we're going to continue doing that today. Okay, so I'm gonna share my screen in a minute, and we're gonna continue reading about the Earth, eclipses, and hopefully you remember about all those things that we talked about last week. Okay, we're gonna do a little review. So let me share my screen. Go ahead and share my screen right now. I want to share this one right here. There we go. Okay, so we were talking about the Earth rotating on its axis last week, and we're going to continue with that discussion today. So this was image daytime and nighttime on Earth. The second way planets in our solar system move is by spinning as they orbit the sun. Have you ever spread your arms wide and twirl yourself around until you were so dizzy you could hardly stand up? Have you ever done that? Can you feel the axis or center line of your body around which you spin? What parts of your body rotate or spin around your axis? Maybe you have played with a spinning top or have seen an ice skater spin quickly around and on one foot. Have you seen those in TV? On TV, yeah. Or have you seen, or this is what it means to rotate. But when a planet rotates, it doesn't twirl around on feet like you do. It spins around an imaginary line that goes from its north pole to its south pole right through its center. This imaginary line is called the planet's axis. Okay, so I'm going to use my whiteboard that I have right here to spell the word, and hopefully you remember how to spell it from our last read aloud. The word is axis. Okay, so hopefully everyone can see it. Okay. And one day is the amount of time it takes for a planet to rotate one time around its axis. So the axis is this line that you see right here on planet Earth. A day on Earth is 24 hours. These 24 hours are divided into daytime and nighttime. As Earth rotates, half of Earth faces the sun and receives the sun's light. It is daytime on this side of the Earth, but at the same moment, the opposite half of Earth is facing away from the sun. This side of Earth is not receiving any of the sun's light, so it is dark there. It is the Earth's shadow. It is nighttime. Okay, so this half of the Earth is daytime. So say, for example, when in the U.S., Mexico, and part of Central America right here, when it is daytime, in the other half of the world, like South America, Europe, and everything else that's on this side, the other half of the world, it is nighttime because only one side of the Earth is getting sunlight. And remember, because the Earth is spinning around its own axis. Okay, we don't feel Earth spinning. From our viewpoint, it looks like the sun is moving and the Earth is not. After all, doesn't the sun appear to rise every morning in the east and set every evening in the west? This daily motion of the sun from east to west might make it seem like the sun is moving around the Earth, but it is not. You are moving around the sun. Or really, Earth is. In the morning, the part of Earth that you are standing on is turning away from darkness and rotating to face the sun. When the sun is up at its highest point in the sky, Earth has rotated so you are fully facing the sun. In the evening, Earth turns away from the sun and it becomes dark again. Why is it dark? Because you are in the shadow of Earth. It is night and you go to bed. But as you sleep, Earth keeps rotating on its axis, and before you know it, your side of the world will have turned to face the sun again. You and part of the Earth on which you live will have once moved out of Earth's shadow, and another one will just begin. Days turn into months, and months turn into seasons. What's your favorite season of the year? Fall, winter, spring, summer? You might know what your favorite season is, but do you know what causes the seasons? It's a combination of two motions of Earth we've been talking about. Earth's orbit around the sun and Earth's rotation on its tilted axis. Okay, so the seasons we have, it's both things. When the sun rotates around the Earth, and also the Earth rotating around its own axis. Okay, now think about what your favorite season is. Okay, think about it. Is it winter? Is it spring, summer? What's your favorite season? What's happening to the Earth? So for example, my favorite season of the year is spring. Okay, so if yours is summer, for example, that's when the Earth is closest to the sun, so we are feeling the rays a lot more than we are when it's winter time. Okay. All right, so let's move on to our next, and I'm getting a little bit ahead of myself right here, so we're going to talk a little bit more about the seasons and what's happening in the seasons of the Earth, okay? Summer and winter seasons and the tilt of planet Earth. Remember, an axis is the imaginary line that goes through the center of a planet from its north pole to its south pole and then points out into space in both directions. But a planet's axis doesn't always point straight up and down like the axis of a spinning top. Many planets, including Earth, have an axis that is tilted a little to the side. This tilt is the key to understanding Earth's seasons. Because Earth is tilted, there is a time of year during Earth's orbit around the sun that the North Pole, and therefore the whole northern hemisphere, is tilted in a little bit toward the sun. So if you can see this one right here, the North Pole and the northern hemisphere is a little bit tilted towards the sun, okay? This tilt gives the northern hemisphere longer periods of daylight and shorter periods of nighttime darkness. Longer periods of daylight give the sun more time to warm the earth, so it gets hotter. The tilt of Earth's axis also makes the sun in the northern hemisphere appear higher in the sky at noon. When the sun is higher in the sky, its rays hit Earth more directly at less of an angle. The more directly the sun hits the northern hemisphere, the better job it does of heating that part of the Earth. So it is the tilt of Earth which causes longer periods of daylight in the high noontime sun that makes summer happen. Okay? So, while that's happening in the northern hemisphere, what is happening in the southern hemisphere? Okay, so we're going to talk about that in our next, we're going to talk about that next. Okay, what is happening well, it is summer in the northern hemisphere. Let's see what's happening in the southern hemisphere. Why is it winter on this part of the Earth? The reason again is the tilt of Earth. When the northern hemisphere is tilted towards the sun, the southern hemisphere is tilted away from the sun. This causes the southern hemisphere to have shorter periods of daylight and the sun to appear lower in the sky at noon. Shorter periods of daylight give the sun less time to warm Earth, so it is cooler. And when the sun is lower in the sky, its rays hit Earth at more of an angle or a slant. This angle makes the sun have to heat a larger area of Earth with the same amount of energy. And this means the sun does not feel as warm. The rays of sunlight are less direct and less intense. It is colder, and that's why it is winter. Okay? As Earth continues its orbit around the sun, the axis of Earth always stays pointed in the same direction. So when Earth reaches the opposite side of the sun, the South Pole, instead of the North Pole, is now tilted toward the sun. Okay? This means that the Southern Hemisphere has summer and the Northern Hemisphere has the opposite, which is winter. The seasons in the Northern and Southern Hemisphere are always opposite of each other. This is because only one of them at a time is tilted toward the sun. Okay? So, let's see. So, on this one, which hemisphere is tilted toward the sun? And the hemisphere that is tilted toward the sun, it's the hemisphere that is getting more sun. Okay, so in that part of the world, it is summer, and the part that is a little bit away from it, it's winter. So there's always the two seasons happening in the world, and one half is summer, the other half is winter. Okay, alrighty. All right, so remember the picture that we looked at the beginning of this read aloud? It was a picture that we have right here, and it was a picture of a big city, okay? Like, kind of like a picture that you would find on Google Maps. It's an aerial view of planet Earth. So, you know, the first part of your space address, your school is on planet Earth, and planet Earth is part of your school address. Space address. So now you have more information that you would need to answer an extraterrestrial being that might ask where your school is located in the universe. Our school's name, so we're going to review a little bit. Okay, so I'm going to write our school's address one more time. Our school's name is Nosotros Academy, and I'm writing that, and I'm going to show you in a minute, and I hope you're writing this down as well in a minute. Our school's number and street is 440 North Grande Avenue. Okay, and our town or city is Tucson, Arizona. And the zip code is 85745. Let me write that again because I wrote it really big. Tucson, Arizona, 85745. And our country, we live in the USA, and our planet is, we're going to write planet Earth. And also remember, this is only if you are communicating with an extraterrestrial being, okay? So this is the address, Nosotros Academy, 440 North Grande Avenue, Tucson, Arizona, USA, planet Earth. This is if you were to communicate with an alien from a different planet or a different galaxy. They wanted to know where you're located. They would, you would tell them this. This is the information that you would tell them. You would tell them this is where I'm located. Okay. All right. Fun times as always, right? Okay. Alrighty. So now I'm going to ask you a few questions this is because this is the last part of our read aloud. Okay, I'm going to ask you like 2 or 3 questions this time. Okay, number 1 question. Let's see. Now, question number 1. Let's see. What kind of space object is Earth? And why is Earth classified this way? Well, Earth, remember, is a planet, and it is classified as a planet because Earth is a sphere with a large mass. It orbits around a star, which is the sun, remember, and it has cleared most other objects from its path around the sun. Okay, it doesn't make its own light because the sun, which is a star, makes its own light. And this is, if you pretend this is the sun, the Earth orbits around it. Okay, that's why it's considered a planet. So the rest of the planets in our solar system do the exact same thing. Okay, let's see another question. Let's see. What kind of space object is our sun? So we just said that the Earth is a planet. Is the sun a planet? No, it is not. Remember, it is a star. The sun is a star, and it is made up of a lot of gas. Okay, it doesn't have a lot of mass like the Earth does, but it just has a lot of gas, and it gives off constant light and heat. That's why the sun is classified as a star. Okay, I'm going to ask you one more question. Let's see. The question I'm going to ask you. Okay, let's go back to our read aloud and let's talk a little bit about what happens during different eclipses. Okay, remember we talked about the word eclipse. Oh, I went a little too far back. Okay. So what happens during a solar eclipse? Okay, solar eclipse, sunlight is blocked from Earth because the moon passes directly between the sun and Earth. So the top one is a solar eclipse. The moon is between the sun and the Earth. So you can't really see the moon, okay, because you only see a little flare around it. What's another type of eclipse? Another type of eclipse is the eclipse that we have down here, and it's called a lunar eclipse, and is when the Earth is in between the sun and the moon, okay? And it is blocking the sun's light from reaching the moon and casting Earth's shadow on the moon. That's the difference between a solar eclipse over here and a lunar eclipse. All right, lunar because it refers to the moon, solar refers to the sun. All right. Okay, boys and girls, that is, oh, one more question. This is the last one, I promise. Okay, so this is the sun right here, as you can see, and we have the Earth orbiting. I'm going to write that word on our whiteboard because that's an important word that we need to remember. The Earth is orbiting. The Earth is orbiting the sun in something that we call, in a shape that we call ellipse, and it's very similar to the shape of an oval, remember? So the Earth is orbiting the sun in something that we call an ellipse, and an ellipse is like an oval. It's in an oval shape, okay? And that's what you see right here, okay? The Earth is orbiting the sun. That's why we call that an ellipse, because it's not quite round. It's not a circle, but it's more like an oval, okay? All right, boys and girls, so that was the last question I was going to review with you during this read aloud today. And come back tomorrow for another read aloud related to the solar system. We're going to be reviewing our planets and talking a little bit more about them and what they do and everything related to our universe. Okay? All right, boys and girls, see you next time.